Hey all, welcome back to another video. In this video, we are going to understand deeply about what DSPy is and how it actually works. So, DSPy is an open source framework built around a very simple but powerful idea. Stop treating LLMs like chatbots and start treating them like programmable components. If you ever struggled with brittle prompts or unpredictable outputs, DSPy solves these very issues. So today, most LLM applications are built by writing prompts. We encode logic inside natural language, we add examples, we tweak the wordings, and when things break, we tweak again. The problem is not the prompting is bad, it's just that the prompts are a mix of task definition, reasoning strategy, formatting, and examples. DSPy separates these components. DSPy asks a more fundamental question. What is the task and what structure should its input and output follow? DSPy lets you declare tasks using Python code and then automatically generate, executes, and optimizes prompts for you. DSPy is often described as a compiler for LLM and not a Python library. The most important mental shift with DSPy is an LLM call is not a conversation, it's a function call. Inputs go in and structured outputs come out. And the first building block is signatures. It's a typed interface between your program and the LLM. It defines what inputs are required from the user and what it should output, and how the outputs should be parsed. Let's use sentiment analysis as an example. So here is the basic code. Now let's slow down and really understand what this signature is doing. This class is not a prompt. It's also not model logic. It's a schema, a strict description of how data should flow between your code and the LLM. So what this signature actually enforces? First, we can see that it can take a text as an input, like whatever the user gives will be taken as a text input, and the output is very clearly defined as sentiment. So within the sentiment, it can only give three different outputs, positive, negative, or neutral, all defined by the programmer. Now, the model can't return paragraphs, explanation, or random text. We make sure the LLM only gives one of these three responses. Second, it gives DSPy something very important, a parsing rule. DSPy now knows exactly what type of output should be given and how it is validated. So there's no need for any manual parsing of text anymore. Now the third logic is it completely decouples logic from wording. If you change the model or the prompt style or the reasoning strategy, the signature does not change. Maybe you can change from chain of thought to some other reasoning style, but the signature remains as it is. We are not going to touch the signature. It goes all along as the project changes. So that your application logic stays stable. Now let's talk about what actually happens when you run this code, this particular code. This looks simple, but DSPy is doing a lot of several steps behind the scenes. So the first one is DSPy looks at your sentiment signature. Again, as I explained previously, it takes an input, then it gives an output, positive, negative, or neutral, and then allowed values for the output. All of them are clear. Now, at this point, DSPy understands the shape of the task, not the language yet. The next, DSPy converts the signature into a prompt template. So conceptually, it becomes something like, given this input text, produce an output called sentiment that must be one of positive, negative, or neutral. Now we have to understand that this prompt wasn't created by the programmer. This was created by the DSPy framework. It now sends the generated prompt to the LLM depending on the module. We can ask it to predict for a direct answer or use chain of thought, or else we can ask it to use tools. We'll learn more about this later in the future, in a few minutes. Now the generated prompt is given to the LLM. Now, depending on the module, we'll be learning about module in some time. So as of now, I'll just briefly explain. We can ask the LLM to predict the answer, give the direct answer, or use chain of thought, or use React, which allows tool usage too. DSPy allows to use tools and functions. More about that in a few minutes. Now, DSPy parses the output. When the model responds, it parses the response using the signature. First it extracts the sentiment field. Oh, I made a mistake in the field spelling. Okay. Extracts the sentiment field, checks if it matches one of the allowed values, and converts it into a Python object. So even if the parsing fails, the DSPy knows something went wrong. DSPy returns structured data. So here we can see it returned negative. For the input, the movie was slow and boring. This is why the output feels like a normal Python object. You're no longer dealing with strings, you're dealing with structured data. Moving on to modules. If signature defines what the task is, module defines how DSPy tells the LLM to solve the task. DSPy ships with multiple built-in modules. First of them is predict module. So here, the predict module is the simplest possible module. Internally, predict tells DSPy, given this input, produce the output directly. Don't do extra thinking. There is no explicit reasoning request, no intermediate steps, or no usage of tools. Now, DSPy generates a single prompt, makes one LLM call, and parses the output using the signature. So when do we use this predict module? When the task is straightforward, or when you want a faster execution of the task, or when reasoning, or you feel like the reasoning is unnecessary for your problem. And to further elaborate it, like classification, tagging, or extractions, we can use predict module. Now next. Oh, I explained this previously. Next being chain of thought. So chain of thought changes how DSPy constructs the prompt. Instead of asking only for the final output, DSPy explicitly instructs the module to reason step by step and then produce the final answer. So crucially, DSPy does not mix the reasoning step and the final answer together. They treat both of them separately and thus giving much better outputs. So chain of thought doesn't make the model smarter, but it makes its thinking visible and controllable. Moving on to the next one, React module. Reason plus act also, it stands for that. Now, instead of answering immediately, the model can decide to take an action and call a tool if necessary. So here we can see we're using the React one. And here we can add the tool that we are supposed to call for the particular query. And you guys might wonder, what is this arrow mark, question to arrow mark? I'll explain this in the next topic. So in predict and chain of thoughts, the model only produces text. In React, the model participates in a loop. First it thinks, takes an action, observes, and again it starts thinking. So DSPy manages this loop for you, and you need not write any complex prompts or parsers. Everything will be done by DSPy. Shorthand signatures. This is what I was going to explain. Now, this is not an executable logic. It's just purely declarative. What this line means, so everything on the left of the arrow is the input and everything on the right is the output. The types tell DSPy how to format the prompt and how to parse the response. So here we can see there is text, but instead of text, you can also have integer as an output or a float value as an output. Now we are moving to tools and adapters. DSPy is not only limited to text-only reasoning, it also incorporates external tools for the model to use. And one such is PythonInterpreter. This allows the model to execute Python functions safely. And instead of guessing answers, the model can compute them. So the model reasons about the problem, decides to use Python, executes the code, and runs the computed result. This eliminates all of the hallucination in math. You can add tools this way. Now moving to Colbert V2. It enables retrieval augmented generation, nothing but RAG. Instead of relying on model memory, this program can retrieve relevant documents when required. The retrieve context is then passed to another DSPy module, and the retrieval becomes explicit and modular. Or we can just implement RAG using this set of code. Best of n. Sometimes a single LLM call is not reliable. The model might give a shallow answer or a partially wrong answer or a low quality reasoning path, any of them. Now, best of n solves this by running the same task multiple times, as you can see, run 1, 2, 3, 4, 5, and then selecting the best output out of them. Now, here we have defined n value as 5. That's why it ran 5 times. This is very programmable. Depending on your use case, you can change it. And then DSPy applies a selection strategy, often based on confidence structure or any metric. And then it gives one final output. The best answer would be given as the output. Moving on to multi-chain comparison. So sometimes the problem isn't getting an answer, it's deciding which reasoning path is correct. Then multi-chain comparison explicitly compares all of these multi-reasoning chains and selects the best one out of this. So it compares, evaluates, selects the best chain, and then gives that as the output. Again, the comparison logic is internal, only you need to write the best final output. So here you give the question and then you'll ask it to generate the answer. This is how your signature is. And here we give a question, should electric cars replace gasoline cars entirely? It thinks about it and chooses the correct reasoning path, compares, evaluates, and chooses the correct reasoning path, and then it outputs the best answer. Moving on to one of the most important concepts, optimizers. So far we've seen how DSPy lets us define tasks using signatures and control model behavior using modules. Now comes the most confusing but also the most powerful part. DSPy optimizers do one major thing. They automatically rewrite and improve prompts for your specific task using any labeled examples that you provide or a metric that you provide. They do not retrain the model or they do not change the model weights. They only improve how we talk to the model. So now when we build our prompts, we tweak instructions regularly, add examples like few short prompting, then change the formatting, try over and over again. All of these are very tedious and very labor demanding. So instead, DSPy automates this process. Instead of guessing which prompt is better, DSPy tests different prompt strategy and keeps the best one. Think of DSPy optimizers like this. Now your program is incomplete and the optimizer's job is to compile it into a better version by discovering the best prompts internally. That's why DSPy uses the word compile and not train. To use an optimizer, you need exactly 3 things. So the first, a DSPy program like our sentiment classifier, which I showed in the first initial slides. And second being a set of supervised examples. I'll explain a bit more on this later. So a supervised example with an input and the correct outputs. And the third metric, a way to judge if your output is correct. So if the generated output by the LLM is correct. Again, moving on to the sentiment classification task. We give DSPy a few labeled examples like this movie was amazing is a positive statement. This was terrible is a negative statement. So this is our supervised data set. It should be given in a JSON format to the DSPy. And we give DSPy a simple metric. Did the predicted label by the LLM match the correct one? If not, it reiterates the prompt to give the correct answer. Now, what happens during the optimization? First, it creates different versions of the prompt, different instructions and different example formats. Second, it runs your program on the training data, like what I explained previously. And third, it scores the results using your metric. And finally, it keeps the prompt version that performs the best. And all of these happen automatically without any manual intervention. What gets optimized? DSPy can optimize instructions, formatting, few short examples, and the reasoning structure. It cannot magically make the model smarter. It only makes your interaction with the model better. Now, how do we code optimizers? These two code was previously shown in the video, and here's where we're going to focus on. Now we're going to create a variable optimized model. There we'll use this word called compile. So DSPy is freezing the best performing prompt strategy into a reusable program. From this point on, every call uses the most optimized prompt. So here inside we'll give it the sentiment model and the training data set for the for the optimized model to learn. Now, DSPy, the compile, helps in finding out the best performing prompt and then use it for future question answering or reasoning tasks. And then for that, we'll be giving sentiment model into this, the signature, and then the data set that we talked about, train set data set. So before optimization, your program might behave inconsistently, and after optimization, it is more consistent and accurate. And the most important part is it's more predictable. And we didn't even touch a single line of prompt. All of them were done by DSPy's framework. When you should use optimizers? We should be using optimizers when your task has any clear or correct answer, that it has only this specific answer, or if your structure matters, or if you have any labeled data that the model can or the prompt can train on. Now, what you shouldn't be using for is definitely not for creative writing or open-ended generation or tasks without any clear metric, because you will be limiting the LLM for absolutely no reason. So again, let me explain what optimizers are in one line. So DSPy optimizers automatically search for better prompts using label data and a metric. They don't retrain the model, they only improve how we talk to it. And that's it, guys. We have come to the end of the video. So let me just give you a quick summary of what we learned. Now, DSPy isn't trying to replace LLMs and it isn't trying to make them smarter. What DSPy really does is it brings software engineering discipline into how we build LLM applications. Instead of writing prompts, we define signatures, clear input and output contracts. Then instead of relying on vague instructions, we use modules. And instead of manually tweaking the prompts, we use optimizers. The biggest shift DSPy introduces is not technical, it's conceptual. You stop thinking in terms of conversations and start thinking in terms of programs. That doesn't mean DSPy is always the right tool, but if you're doing open-ended creative writing or quick experiment, traditional prompting might sound enough. But when structure matters or when the correctness matters, or when your application grows beyond a single prompt, and DSPy gives you a much more scalable way to think. And here's where I'm going to end it. If you watched the whole video, please do subscribe and like it. And if you have any doubts, just put it in the comments. I will surely reply to it. Thank you.